Alright, so in the first part of this exam we were asked to find a way to divide the line into 3 equal parts. I have put in the playlist the construction on how to do that, so please go back and watch. Make sure you know your constructions. I'm pretty much banking on at least one of them coming up for us. And one thing to note that I don't have here is the construction lines. So if you find you had to use your compass for whatever reason, you might have found that you've got lines like this, and you were trying to find the point of intersection of those two curves using your compass. That needs to be left on the diagram. So I wasn't able to do it on the computer, so that's why they're not here. But please go back and watch that video. Do not rub out any of your construction lines. So this part is going to focus on part B. It says label all the points and show how there are at least 2 similar triangles present within this completed construction. So you can label them whatever way you like, but I'm going to call this one A, then I'm going to go B, and then I'm going to go C, and then I'm going to label them whatever way that you want. It doesn't really matter. D, and then I'm going to say E. Okay, so it says show how there are at least 2 similar triangles present within the completed construction. So similar triangles, 2 similar triangles. Another way of saying similar triangles is that they're equiangular, equiangular. All of the angles are the same. Okay, that's what we need to be thinking about here. I need to find 2 triangles within this construction diagram that gives me angles that are the same. So I'm going to draw out, if we look at this, there is clearly 2 triangles. So here's one triangle in the green. So I'm going to redraw that out down here, and I'm going to label the points down here as well. You had to draw this to be able to get out what they were asking for. So I'm going to draw that. That's going to be A, that was B, and this was E. I'm also going to use this bigger triangle that we have up here. So there's this guy in the green. Now, in the pink, when I draw that one out, it's very similar in shape, at least, so we've got that much. And I want now to mark in the sides again. So that was A, this was C, and this one was D. So again, if I want to prove 2 things are similar, I really want to show that they have 3 of the same angles and that those angles match up in the same orientation. Now, when you did that construction, you would know that those lines are perpendicular. So both of those, right off the bat, both have 90. So what I can write down then is that those 2 angles are the same. Now how do I write that? I'm going to write the measurement of the angle ABE is equal to the measurement of the angle, so the measurement of the angle ACD. And now there was one thing right away that you could pick up marks for instantaneously. Okay, so we drew out our sketch and we're just pulling out what angles are the same. If we look at the other ones, and if I go back up to the sketch, this angle in here is common to both A in this triangle and A in this triangle. So those are the same. So I can say EAB, so the measurement of the angle EAB is equal to the measurement of the angle DAC. So there's 2 of the angles. Now, all of the angles in a triangle add up to 180. So if we know that's 90, and we just say, for the sake of this discussion, that this is 60, then you must know that this one up here is 30. And if that one up there is 30, then this one up here has to be 30 as well, because that's 60, which is the same as this guy, and 90 is the same. So those 2 are the same as well by default because of the angles in the triangle. So that's it. Those are the 3 angles. We're showing that the triangles are equiangular. We've got similar triangles. So we've got BEA then, so the measurement of angle BEA, so that's BEA, is equal to the measurement of the angle CDA. And then we would have to say, as the 3 angles align and are equal. We have at least, there could be more, at least 2 similar triangles.